Hello and welcome everyone. Let's continue with the Shantprasad list by solving the middle of the linked list. So we're given a linked list and we want to get the middle node of this linked list. And if there are two middle nodes, we return the second middle node. So this is fairly straightforward. We can clearly see that 3 is the middle node. But if we're given something like this, then in this case we have two middle nodes, 3 and 4, but they want us to return 4, the second middle node. So let's give ourselves some room and approach this using two different ways. So the first approach is going to be the intuitive one. Let us say we have 1, 2, 3, 4 and 5. So what we can do is basically get the length of this array. We can get the length by traversing this entire array and storing the length. This is not like an array, this is a linked list. So to get the length of this linked list, not array, I think I said array, to get the length of this linked list, we would have to traverse this entire length, right? And after getting the length, we know that just like in a binary kind of operation, the length divided by 2 is going to give us the middle. And since this is 5, then if we divide it by 2, we have to floor it because this is 2.5. So if we floor it, we are going to get 2. And the element at position 2, 0, 1, 2 is going to be the element at the middle of the array. So first we are traversing to get the length, and then we are traversing to find the middle element. If these were 6 numbers, so we would have 6 modulo 2, or rather floor 2, this is going to be 3. And if we come 0, 1, 2, this is 3, this is our middle number. So this works fine. And this is going to be a linear time operation, contrary to what I thought. I initially thought this was going to take a O of n squared operation, but this is going to be a linear time, and let me explain why. So first we are traversing to get the length. We are running a traversal, and we know that traversal is going to run in O of n time, right? After this traversal, then we are again running another traversal to get the element at this position. The first thing is that we're not actually going to get to the end of the array in most cases, or we might if we're given a number like 1 or 2. So this is going to also take a linear time operation. But this runs concurrently. It is not running, it runs simultaneously rather. It's not a nested operation. So we're not going to be doing the O of n times O of n. Instead, we'll be having O of n plus O of n, because one runs after the other, in which case we'll have O of 2n, and we know that the constant is negligible, and so this is O of n operation. And so this is also going to be running in constant space because we're not using any extra data structure to store our data. The second way we are going to solve this is by using the Floy'd cycle detection algorithm, also called tortoise and hare, where we have two pointers, right? They are traversing the list, but they are running at different spaces. The first one is running at a speed of 1 or 2 or whatever, but the second pointer is definitely running faster than the first pointer. In our case, our slow pointer is going to be running at a speed of 1, and our second pointer is going to run at a speed of 2. And the way this algorithm works is that this slow pointer is now here and the fast pointer is now here. And at the point where this fast pointer is here, this slow pointer would have taken its second step. At the point where the fast pointer can no longer move, then we can be assured that we've gotten to the middle of the linked list. The slow pointer is going to be at the middle of the linked list, and basically that is just how this algorithm is going to run. Let's jump to the code and write this out. So the first one we are going to solve basically is we're going to solve the brute force approach, where we want to get the length of the list, divide it, and find the middle. This is going to be a little bit lengthy. So first, the length of the list is going to be 0 because at first we don't know. And I want to keep a pointer to the head of the array because we don't want to lose our head yet. So while we still have node, then we want to increment our list by 1, and we also want to move our pointer. We want to traverse the entire linked list. This is basic traversal for our linked list. So at the end of this traversal, we can be rest assured that we already have the accurate length of our linked list. So we want to find the middle, which is going to be linked lists divided by 2, and we want to keep our position as 0, right? The first node in the linked list is going to be at position 0, and this is what we want to represent. So now we can directly reference our head, while head is constant. If position that we currently are is at any point equal to the middle, then we know that we have found our middle and we want to return the head. Otherwise, we want to increment our position, but before we increment, we want to move our head. And this is going to run fine. We know that we are going to return the head at some point, and we can just submit this, and we can see that this runs right now. So let us solve for using our Floy'd cycle detection algorithm. We can say slow and fast is equals to head. This basically is assigning slow to head and fast to head, if you are not familiar with the way Python works. And while we are still in bounds, we want to increment, we want to take a step basically. So we are moving our slow pointer by 1, and we are also moving our fast pointer is taking 2 steps. And we know that wherever our slow pointer ends is going to be our middle of the linked list basically. So wherever the slow pointer ends, that is the middle. And we run this, and we can see that this also runs. So that is the end of this video. This is the solution to this problem. If this was a bit helpful, I hope you subscribe and stay tuned for the next episode. We are currently going through the Sean Prasad patterns, and so yeah, we have quite a list to burn through, and I hope you stay tuned for the next episode. Thank you for watching. Bye.